Okay, I'm going to move on to the next presentation, and I'm conscious that on this site we don't have any box storage, and that there will be people within the audience who have box stores, so I felt it would be good to start by just talking about some box storage issues and covering those off as best we can. Happy to talk in more detail in the workshops this afternoon. There will be presentations about some of the work we're doing, particularly on CIPC and on store auditing. But I thought it would be good to start with an overview of some box storage optimization work that we're involved with at the moment, and just discuss some of the issues and some of the challenges that we've got in box stores in general. So we've got box storage pretty much universally within the fresh market. We've got box storage pretty much universally within the seed industry. And we've also got a significant amount of box storage that is servicing the long-term processing sector. And a lot of that has refrigeration, which fits in with what Peter and John were just saying. The challenge in these stores is really to try and raise the standards to ensure that we can get more uniform conditions across the store. A lot of our problems in box stores are driven by temperature differentials, and temperature differentials generate condensation, and we go from there really in terms of problems in our store. So especially if we haven't got any positive ventilation, achieving uniformity is difficult, and it's also difficult to make sure that those stores run as efficiently as possible. So a number of challenges there which we've been trying to address over a year or two now, and I just want to highlight some of those points and encourage questions and discussion from the floor on those issues. This is all part of a Storage 2020 campaign which we started way back in early 2014, and this was to try to drive this change within the industry. And really, what is it all about? Well, it's about store improvement, trying to get better performance out of what we already have. A lot of people are not in the position where they can build new stores, but we have a lot of storage out there that is aging and needs renovation, but we need to get the best we possibly can out of each and every store. There are no magic one-size-fits-all solutions. We have some basic principles that need to be followed. Every store is pretty much different, despite them looking very similar, but they do all perform differently, and those of you who are store managers will recognise that. And in each case, we have to try and maximise what we can get out of that store, and that also includes the store manager and training. And we set this 2020 date just as an objective over 5 or 6 years to try and get a significant change across our industry, because as the industry rationalises and needs to stay competitive, and we've had some difficult seasons lately which have just emphasised that. So it is important that we get the best out of whatever we have. So fundamentally, in any store, the change needs to be driven through airflow. Air is the way that we manage to change the store condition. And there's some fairly crucial points that we need to consider when we're trying to get the best out of any store, and box stores in particular. Improving the air-to-crop contact is absolutely crucial. If we don't get air and crop in contact with each other, then we're not going to affect any change. And improving the uniformity of air distribution across the store is also crucial. if we're going to get away from these problems of gradients. And that in itself is a challenge, particularly where we haven't got the benefit of positive ventilation. How do we achieve this? Well, one of the main routes that we are currently advocating is the addition of an air divider curtain, sometimes called an air separator. Essentially, if we put an air divider curtain into a store, it prevents short-circuiting. It means that all the air that is delivered from the overhead throw type of system, which is this is where these are most applicable. We've got an overhead throw type of discharge, then that air divider curtain prevents that circulation, or the short-circuiting, I should say, happening here. It means the air has to go to the end of the store, it has to return along the pallet apertures all the way along the store, and then we get an air roll, if you like, or an air circulation around the store, which means we deliver air here that is capable of picking up heat, and we put it to a point where as it gradually comes back, it picks up that heat and it's doing the maximum work for us before it returns to the fans. So if the air can short-circuit that system, it will do, and it won't do the best job for you. So this has been a relatively simple change that we can make to a store. Cost is around £3 a tonne, and I think it's well worth investment in any overhead throw store. If you're going to improve its performance straight away, then look at one of these systems. This is some work we did back in 2011-12, looking at these type of curtains, and we got much more uniform distribution laterally across the store. The amount of air coming down this column was similar to the each column, and we had a gradient of heat being picked up across the store as the air went back. You still have the potential with a very high airflow to get some localized effects here of the negative pressure caused by the fridge coil. These are relatively minor, but still are areas which we are working on trying to eliminate from any store that's got that type of system in it. But the air divider curtain overall is giving us much better performance. If it has a deficiency, it's perhaps just up in this corner here where we get some leakage through the boxes closest to the curtain, and you can see a dip of temperature there as a result of that. It's a compromise that we have to accept. If we go just back to that previous slide, the air route through these boxes that are right close to the curtain is still quite short compared with the whole of the store, so there is a tendency for a little bit of leakage through these front boxes, but nevertheless it's a huge improvement over not having one. The alternatives are generally more expensive. This is a positive system, and converting a store to a positive system like this is going to be a much more expensive arrangement. Basically, the air in these stores moves laterally through the boxes from the positive side to the negative side. So you've got negative pressure under these covers, air being extracted back to the fans, and the air moving sideways through the boxes. Solid-sided boxes don't work very well like this. Slatted boxes do. Ideally, we need new boxes with solid long sides and slatted short sides. But in a new installation like this one, then that's obviously can be built into the design. So the advantage here is we've got true positive ventilation. All of the air is passing through the potatoes, as opposed to in a conventional store, passing down the pallet slots, but not actually being forced through the prop. Another solution is to look at this type of arrangement where we essentially build in a diffuser into the store. This is doing the job of trying to spread out that airflow laterally by putting in a restriction at the back of the store. So these pallet slots here you'll see are much smaller than conventional ones, and they're basically putting a back pressure onto the system. You're getting a throttle at that point, which means that the air is drawn more uniformly right across the whole of the suction wall of the ventilation wall. So this is another solution that has been tried quite successfully, works quite well in small stores. Larger stores not quite so good, but certainly worth considering in a new installation. And then we've got the option of almost tailored ventilation for each column of boxes, which is provided by this type of solution. So you've got an individual fan ventilating each column with a return air coming back over the top, being sucked through the boxes, and the fan speed is regulated by the temperature of those boxes. So each column ends up with a individual ventilation arrangement, which is very luxurious but also quite expensive, as you can imagine. But I know some of the centralized pack houses have been using these types of systems because it does mean they can manage each lot of potatoes individually as they put them through their process. There are other solutions. These are subject to current research. Adrian and Mike will be talking about the CIPC research in the workshop this afternoon, but this is one current investigation that we have going on with levy-funded CIPC research, where we've got a stack of 6 high boxes, and basically we're delivering air into the bottom 2 slots and sealing the sides on those boxes, so there's no air escape elsewhere, and it essentially becomes a quasi-bulk store. We're putting air in at the bottom and pushing it through to the top, and we're looking at this as a possible solution for processing box stores. And I don't know whether this is going to be successful, but it's certainly worth us looking at it. At the moment it's very much an experimental setup in one store in Yorkshire, but if it is successful, then it shouldn't be too difficult to engineer ways of achieving this in practice. But at the moment we're awaiting data to tell us whether this is going to work better. Certainly from a CIPC perspective, being able to deliver the CIPC through the potatoes in any box store is preferable to it being put into the roof space and ending up on the top of the boxes, which gives us a risk of MRL exceedance. So we shall continue to investigate options like this as part of our research program. The disadvantage with this is that it is relatively expensive in terms of research to do this in commercial stores, and we only get one result per year, so it's a slow and sometimes frustrating process to go through, but we're hopeful that we may have a solution to that. We've got 2 new projects starting soon which have just recently received funding. We have an Innovate UK 8-partner industry project which is going to be looking at the development of computational fluid dynamics modelling and to model solutions and provide improved CIPC control in potato storage. That starts very shortly. And we also have a PhD project which is going to happen just down the road here at Harper Adams, which is going to look at specifically at the CFD methodology and refining that. But at the moment, none of this work has started, so it's very early days to say exactly what we're going to achieve with it. But the potential advantage is that we will be able to model any store on a computer and find its optimum airflow arrangements and CIPC distribution arrangements without having to do a lot of empirical research in the way that we're doing it at the moment. So it's a case of watch this space, and we'll keep you updated on how that develops. Other areas of storage that we can look at for change, addressing issues such as leakage, and we've got a demonstration this afternoon on the store check process looking at air leakage. All of our stores work really well when we can control the environment. None of them work very well when something else is controlling the environment, and if that's an ingress of outside air due to climatic conditions, then that's basically going to cost us extra money. Whenever something changes in the store, we've got to put that right, and that usually means using electricity to do that. In some of this work, we've found that air leakage can be responsible for as much as 50% of a store's energy use. So if you've got a very leaky store, it can be extremely damaging to your running costs. And the store check process does allow you to assess individual stores and see how they perform. Another area which has already been mentioned is refrigeration, but getting the best out of a refrigeration system is crucial as well. And there are a lot of steps in the process where things can go wrong. So the first one I've been talking about is really how we get that heat transfer from the potatoes to the air. How do we get the air circulation right so that we get heat coming out from the crop into the air? But then when we've got a refrigeration system in place, then we've also got to have efficiencies elsewhere. You've got a heat transfer process that takes place when that air hits the refrigeration coil. That needs to be as efficient as possible. We need to get as much of that heat to the fridge. We've then got the refrigeration system itself, and Mike's talked about refrigerant charges. Essentially, we've got that heat transfer taking place through the refrigerant. So if the refrigerant isn't optimized, then that process becomes hampered. And then we've got to get rid of that heat outside of the store with the condenser set. And if that condenser set isn't using the whole of its coil area, for example, then the efficiency is going to be reduced. And a lot of the old condensers have multiple fridge systems, multiple fan systems on them. Excuse me. A lot of those fans shut down when there isn't full demand, whereas some of the new ones have variable speed fans on them and use the full set of the condenser to get rid of the heat. So a lot of heat transfer process is taking place. If we don't get rid of the heat at this point, it goes back into the store in the refrigerant, and the heat extraction capacity for that fridge is reduced. So it is important that we get rid of the heat, and we measure the whole process in terms of coefficient of performance. And we've had data in our work which has measured coefficient of performance ranging from 1.7 to 4.4. So that's 1.7 kilowatts of cooling for every kilowatt of electricity. Not very much there, but on average we'd look for about 3. But in the best fridges, which have got all of these processes optimized, we've been getting up to 4.4. So that's quite a significant, almost threefold difference between the best and the worst there. And so it is crucial that if you've got a fridge, that you make sure it's working to the best of its ability. Similarly with fans, we need fans to work for us in the best possible way, and a lot of the old stores have got a single fan in them, or two single fans which just are on or off, and that means that we don't necessarily get the best from those. We can get much better performance out of a fan if we've got an inverter control on it. We can vary the speed according to the requirements of the store, and we can also get energy savings as a result of not using full speed if that's appropriate, and in some cases that is appropriate. In some of the refrigeration systems it may not be, but we'd encourage you, if you've got old fan systems, that you talk to your supplier to make sure that at least you have that discussion and debate as to whether the fans you've got in place are giving you the best performance. It may be more cost effective to throw away a fan and buy a new one to reduce the energy consumption and get your payback that way, because you're probably spending more on electricity over a season than the cost of the fan in the first place. So certainly have a look at that both in box stores and in bulk stores. Humidification has also got lots of potential, particularly in new installations, but does have scope in retrofit up to a point, and it has the potential to extend the use of ambient air by evaporating water to get the temperature drop that you want to cool the crop. It is best suited to processing stores, but in all cases where we're using humidification, we do have to understand that if we haven't done all the bits that I've been talking about temperature control and got that right, and you've got temperature gradients in your store, then the more that you humidify, the more you move towards the point of saturation and potential condensation. So if you haven't got your temperature control sorted, don't go down the humidification route. If you have got a good setup, then humidification has the potential to add something extra for you. Another important point is to know what your storage is costing you, and we still have far too many stores where we don't have individual meters in stores, and so we don't really know what storage is costing. And the work that we've done, again, just going back a year or two now, but illustrated that we've got something like a threefold variation between the poorest stores and the best stores in terms of their energy performance. And if you're running a store at the bottom end of that range in terms of efficiency, then you're going to find it difficult to compete with those stores that are much more efficient. So do get out there and talk to your electrician. Heel Farms have got their electrician on site today. Talk about putting in individual meters and get the data recorded so that you know what's happening. The other advantage with this is that you can then link into something like our new storage calculator, which is being demonstrated here by Nick Blake from Anderson's. It's going to be launched very shortly, and we're just finalising the program. So do have a discussion with Nick, because we can put this information into that storage calculator, and you can see very clearly what your storage costs are and how those relate to the payback that you're getting for your crop. So it does give us some really important tools for improving the returns from storage if you follow this route, and I would very much urge you to do that. From an AHDB perspective, it's important we get the messages across to you, and we have the interactive potato store system, which is going to be opened up more widely in terms of access. We've had an issue with logins and things which last year, which was not working particularly well. We're going to try and widen the access to this system, and you will find this as a one-stop shop for information on storage in due course. I'm hoping to rewrite the Store Manager's Guide and link it into here as well. So do visit the TIPS website to get information on storage. And generally over the next 10 years, I hope that we can improve our storage, make it more viable, efficient and effective. We are looking at integrating agronomy and storage much more in our research programs. It's important when we're storing that we understand what's gone on before in terms of the agronomy of the crop and the seed of the crop, and some of the systems such as the one that John Kemp is demonstrating today are helping us to be able to do that. It will also hopefully improve our ability to predict what happens in storage more. We're not very good at that at the moment, but we need to get much better. We need to encourage investment in the storage just as much as we do in machinery and other things with four wheels on them, and invest in the people and the skills to do the job. And I hope that then we will see a sustainable solution to our potato storage for the industry to go forward with over the next 10 years or so. So there's some advice always available from us at AHDB, so please contact us